Okay, so in this third part of the chapter, we're going to look or finish the functions of the brain and look at the reflexes. And so here, the thalamus, we need to know that the thalamus sorts, edits, relays impulses to appropriate destinations. So what this means is that the information first comes to the thalamus decides what to do with it, and then sends it to the appropriate place for it. So let's say it's the visual information has to stop the thalamus and then go to the occipital lobe. Or if it's the hearing information, stops the thalamus, then goes to the temporal lobe. Okay, then next, the hypothalamus. This maintains homeostasis. It regulates our internal organs. So for example, heart rate. Next, the brainstem. You need to know the three parts that make up the brainstem. There is the midbrain, the pons, and the medulla oblongata. So what you're seeing in this picture, the upper part says the corpus callosum, but then the brainstem is this bottom part. Okay, so just above the pons is the midbrain. The pons is the belly shape, and the medulla oblongata is the bottom part. First, we'll start with the midbrain. So the short section of the brainstem lies between diencephalon and the pons. But what we need to know, in the midbrain, there's this region called the substantia nigra. This region is important for movement. It secretes dopamine. Dopamine is controlling our voluntary muscles. Parkinson's disease is the degeneration of this area. Okay, you don't have to identify it on the picture, but we're seeing here, they labeled it right over here, substantia nigra region. And so this picture is when it's cut horizontally. And so our book just talks about the Parkinson's disease, and so it's just basically saying the same things. The pons looks like the bulge or the belly shape between the midbrain and the medulla oblongata. This also helps to relate impulses, but for the pons especially know that it regulates our breathing. And then next, the medulla oblongata. This area of the brain controls our internal organs. If this area is damaged, then it can be life-threatening. And so this contains the cardiac center, vasomotor, meaning controls our blood vessels, and respiratory control center. Then it also has these reflex control centers. And so it says here injuries are often fatal. Okay, so know that our heart rates, our breathing is very much controlled by this area. Okay, next the brain waves. Brain waves are just basically looking at the electrical changes in our brain recorded from the electroencephalograms, EEGs. And so here electrodes are just put on the scalp to pick up these electrical activities. What this is showing is the different waves. Alpha waves are for awake, resting. Beta waves, when you're thinking. Theta, most seen in children. Delta, mainly during sleep. But you don't need to memorize these different types of brainwaves. Just know what brainwaves really look at. Okay, so the brainwaves can be recorded during sleep. We have the two different types of sleep. We have the REM sleep and the non-REM sleep. Okay, we need to know that during the REM sleep, dreaming occurs, but also during this time, our muscles are paralyzed. Only the ocular muscles, meaning the eye muscles, and the diaphragm or the breathing muscles are working, but the other muscles are paralyzed. Then the non-REM sleep, we go into this after the REM sleep and then go into the cycle of REM, non-REM. But so during this time, the person is able to actually walk around because the muscles are not paralyzed. And so during this time, what can happen is sleepwalking occurs here, bedwetting, night terrors, meaning the person's acting out their dreams. So here in the sleep cycle picture, we're seeing here awake. So then when you fall asleep, first you go into the REM cycle. So this is what this pinky part is. Then after you go through the REM cycle, which is during the time when you're dreaming, then you fall into the non-REM. And the non-REM has these 4 different stages. The fourth sleep is the deepest sleep. Okay, then you go back up. And so you can see at the bottom are the hours. You go back up to the REM cycle, then fall back down. And you can see that the more hours you sleep, the less time you spend in the deep sleep. Cerebellum, the little brain. This is important for muscle activity, but also really more important for balance, coordination of movements. That tree shape on the cerebellum is called the arbor vitae. Arbor vitae is actually just white matter. That's why you're seeing the difference in the color. But so here you have the myelinated axons in the arbor vitae. The other parts of the cerebellum, that's the dark matter. So the dark matter, you have the cell bodies, the dendrites of the neurons. Okay, so again, the cerebellum is for balance, regulates our movements, maintains our posture. Our spinal cord. Spinal cord's actions is for spinal reflexes, but also it acts as a road, a pathway for impulses to go up and down. And so here, spinal cord gives off the spinal nerves. Okay. The spinal cord actually ends at about L1 region, meaning the first lumbar region. Where it ends, that's called the conus medullaris. But just because it ends doesn't mean that the nerves end. From the conus medullaris, many nerves come out. These nerves kind of looks like hair. They call it the cauda equina, which translates into the horse's tail. Okay, so then these nerves then go to the lower limbs. And the filum terminale, this is just pia mater. It's not a nerve, but this is just to connect the spinal cord down to the coccyx so that the spinal cord stays in place. Okay, so know what these different parts are. Conus medullaris, where the spinal cord ends. Cauda equina are just the nerves. Filum terminale is just pia mater. The different parts of the spinal cord is shown the cross section or the horizontal cut. Here, the inner part, this butterfly looking part, that's just the gray matter. Okay, then the area around is the white matter. Okay, so from the gray matter, we're getting these branches coming out. This branch goes to the dorsal side. That's the dorsal root. The dorsal root then connects to this bulged area. That's the dorsal root ganglia. The dorsal side carries the sensory information. Okay, so here, for example, touch from the skin would go through here and then go into the gray matter. The other side, ventral root. The ventral root region does not have that bulge that the dorsal side does. It's not there. And so the ventral root carries the motor information. And so the information going to our muscles are then going out through the ventral root. This here, separation in the back, a little bit of separation there. That's called the posterior median sulcus. In the front is the anterior median fissure. Okay, then once you know what side is the back, what side is the front, they labeled different parts, the gray matter and the white matter, based on this. Posterior horn is basically this part here, this part here. Lateral horn is just the sides, and the anterior horn, the front part. And so the same thing for the white matter. Instead of the funiculus, you can also use the word column. Posterior column is the back part of the white matter. The lateral column is the side, and the anterior column is then the front part of the white matter. And the last thing that's on this picture, the gray commissure. Gray commissure is just the region here, right in the center, the region going around the central canal. And the central canal is running inside the spinal cord, up and down. And this is taking the cerebrospinal fluid up and down. Okay, so very important function of the spinal cord is the reflexes. So the reflexes are automatic. You don't have to think about it. You just do the action, and then later on you realize that you did it. So in reflexes, we have 3 different neurons that are important. there's the sensory neuron. Sensory neuron picks up the information. Interneuron is going to be in the spinal cord. This is the one making the decision. And the motor neurons then take the information to our muscles. Okay, so just the picture showing the reflex arc. So of course it's very simplified, but let's say the information is coming from the skin. The neuron picking up the information from the skin would be the sensory neuron. Sensory neuron is going to go through first the dorsal root ganglion, then continue on through the dorsal root, go into the spinal cord. Okay, so the sensory neuron stops here. Inside the spinal cord, the neuron is called the interneuron. This is the one making the decision. And then the interneuron sends the information to the muscle through the ventral root. And so then the motor neuron, we can see it going to the muscle here. Okay, so it's just a summary of the reflex arc. And so then on the next part of this chapter, we're going to look at how that knee-jerk reflex occurs or the withdrawal reflex occurs. Oh, and just to reiterate, this receptor just means the beginning of the sensory neuron. And so this is the part that is actually picking up the information. So the sensory neuron brings the information to the spinal cord. Interneuron is the neuron inside the spinal cord. Motor neuron goes to the muscle. And the effector is the muscle or the gland that the motor neuron then activates.